Welcome to Career Guidance Max playlist. So last two videos we seen only the working rule for how to solve zero velocity and non-zero velocity steps. We applied 4 steps. So based on that, in this video I'm going to start the problems in one-dimensional wave equation. So in this also we considered two parts. Part 1 will be type 1 zero velocity. So in this first problem, a string is stretched and fastened to points and x equal to 0 and x equal to L apart. The motion is started by displacing the string into the form y equal to k of Lx minus x square, from which it is released at time t equal to 0. So find the displacement of any point on the string at a distance of x from one end at time t. So is this our problem? So first of all we have to identify this problem under zero velocity or not. How to identify? Here they are not mentioned any velocity function. Here not given velocity, so which is zero velocity. Here they given only the displacement of the string, that is y equal to k of Lx minus x square. Is this our function? When time t equal to 0, it's released that string, you may get some shape. So we are going to find the displacement for that shape. Okay. So in the sum they given the length x equal to 0 and x equal to L, and shape also they given at time t equal to 0. So initially we have to write the wave equation. So that is dou square y divided by dou t square equal to a square into dou square y divided by dou x square. After that, based on the condition, I'm going to write the general conditions. Already you know that. Now I'm going to write specifically for this sum. Y equal to 0 when x equal to 0 will be our first condition, because in the sum they given the starting point x equal to 0. So that, and y equal to 0 when x equal to L. Why I taken L? In the sum they given the length L, so that here I written only length L. So the first two conditions are boundary conditions, because when we taken length x equal to 0 and length x equal to L, okay, one string will be fixed. And next one, dou y by dou t is equal to 0 when t equal to 0. Is this our zero velocity model? Why? Because in the sum they didn't given the velocity. And last one, y equal to f of x. Usually we are writing y equal to f of x, but here we have to write what is that f of x. That f of x is k of Lx minus x square. So depend upon your problem, this f of x will change. Okay, so that is given by the safe k of Lx minus x square y equal to. So we have to find the displacement. That's it. Okay. And when time t equal to 0, this is the shape. The suitable solution, already you know that y equal to a cos px plus b sin px into c cos pat plus d sin pat. Is this our equation 1? So already you know that in this equation 1 we have to substitute our conditions one by one. When substituting condition one by one, you will get the answer. So that applying 4 condition is common to every problem. Already I told that. So in this sum I'm not going to apply all those things. Just straight away I'm going to start with the solving Bn. So before that, just we can recall what is step 1, step 2, step 3. Okay. And step 1, I'm going to apply in condition 1 in equation 1. I will get equation 2. In step 2, I am applying condition 2 in equation 2. I will get equation 3. In step 3, I am going to apply condition 3. Before applying condition 3, equation 3, I am going to partially differentiate. Then I am substituting the condition 3. I will get the most general solution. That is y equal to sum of n is equal to 1 to infinity bn sin n pi x by L cos n pi at by L, which is our equation 4. So from this equation 4, I am going to substitute condition 4, that is y equal to k of Lx minus x square and t equal to 0. In generally, while seeing working rule, Here I substituted generally y equal to f of x and t equal to 0. Here I am going to substitute f of x equal to k of lx minus x square and t equal to 0. When substituting condition 4 in equation 4, I will get left hand side equal to y value k of lx minus x square is equal to right hand side sum of n is equal to 1 to infinity bn sin n pi x by L. So here I am going to represent what is this right hand side value. So right hand side value is represent half range sine series. Half range sine series means we can able to find bn value. After finding bn, you can substitute that bn in equation 4. I will get general answer for this sum. Okay. So consider this k of lx minus x square as a function f of x. Now I am going to find bn. bn is equal to 2 by L integral 0 to L f of x sin n pi x by L into dx. So 2 by L integral 0 to L. Here I am going to substitute f of x equal to k of Lx minus x square into sin n pi x by L into dx. Okay. So from this k is a constant, I am going to take outside 2k divided by L integral 0 to L Lx minus x square into sin n pi x by L into dx. So this term we have to integrate. How to integrate? Here I am going to apply Bernoulli's formula. Already you know that Bernoulli's formula. When we can apply Bernoulli's formula? When differentiation exists, we can able to apply this Bernoulli's formula. The formula is integral uv dx equal to uv1 minus u dash v2 plus u double dash v3. Like that we can write infinite number of terms. In this above integral term, first one I am taking u, second one I am taking v. So algebraic term u, trigonometric term v. U is represent differentiation, v is represent integration. Here I am writing u equal to Lx minus x square. U equal to Lx minus x square. I am going to differentiate with respect to x. U dash equal to L. X differentiation 1. L is constant. And x square differentiation 2x. And u double dash. U double dash equal to L differentiation 0 and minus x differentiation 1. You will get 2. Okay. And u triple dash equal to, when differentiating constant term, you will get 0. Right off. Then here we can take v equal to sin n pi x by L. V equal to sin n pi x by L. I am going to find v1. v1 equal to integral of v. When integrating sin term, I will get minus cos n pi x by L divided by the coefficient of x we have to write n pi by L. Okay. And I am going to find v2 equal to integral of v1. So again cos term you can integrate. Integration of cos sin minus as it is we have to write, and cos integration sin n pi x by L divided by x coefficient n pi by L, already one n pi by L, n pi by L into n pi by L, we can write n pi by L whole square. Okay. And next one, I am going to find v3. v3 is equal to, I am writing integral of v2. Again integrate sin term, sin integration minus cos, minus into minus plus. So cos n pi x by L divided by n pi by L whole square into n pi by L. We can write n pi by L whole cube. Okay. Continuously we can find v4, v5, v6 like that. But here your u triple dash equal to 0. That means we can stop our process up to v3. When we substitute u triple dash equal to 0 means the entire Bernoulli's formula will exist. That's enough. So that now I am going to substitute u v1, u dash v2, u double dash v3. Okay. When substituting u v1, u dash v2, u double dash v3, you will get the answer for bn. After that we have to substitute the conditions upper limit and lower limit. So I'm writing Bn equal to 2k by L by Bernoulli's formula uv1. U is Lx minus x square. V1 is minus cos n pi x by L divided by n pi by L and minus u dash. What is u dash? L minus 2x and V2 is minus sin n pi x by L divided by n pi by L whole square. This is second term and plus third one u double dash into V3. What is that u double dash? Minus 2 and cos n pi x by L divided by n pi by L whole cube. Our limit is into 0 and L. Before applying upper limit lower limit, we can eliminate here sin term. Why? Because when substituting x equal to L, L will cancel, sin n pi equal to 0. So upper limit 0. When substituting lower limit x equal to 0, the entire term 0, sin 0 is 0. So that before applying upper limit lower limit, we can cancel this sin term. So why? Because of sin n pi equal to 0 and sin 0 is also 0. Okay. Then the above term we can simplify. This numerator term I am writing in the upper this denominator term I am shifting to numerator. I am writing L divided by n pi. Here outside you will have minus, taking outside minus, and Lx minus x square into cos n pi x by L. Okay, and plus into minus minus this n pi by L cube denominator term I am shifting to numerator. Take a reciprocal 2 into L cube divided by n cube pi cube and cos n pi x by L. The limits 0 to L. So first I am going to apply upper limit 2k divided by L. When substituting upper limit, here x equal to L, now L into L square, here also L square, the first term 0. Here we can write minus 2L cube divided by n cube pi cube and cos, when substituting here L, x equal to L, L will cancel, you will get cos n pi. So upper limit over and minus of lower limit. So when substituting here x equal to 0 means this entire term 0 minus 2L cube divided by n cube pi cube. Here we can substitute x equal to 0. When substituting x equal to 0, you will get cos 0. Is this our lower limit substitution? And now we can simplify this term 2k divided by L and minus 2L cube divided by n cube pi cube and cos n pi we can write minus 1 power n. Already you know that cos n pi equal to minus 1 power n and minus into minus plus 2L cube divided by n cube pi cube. Cos 0 is 1, we know that. So now from this I am taking outside common term 2L cube divided by n cube pi cube and remaining term we can write 2L cube divided by n cube pi cube I taken outside. So remaining you will have 1. This term plus and this minus, you will have minus 1 power n. Okay, now simplify this. When simplifying this, L will cancel, you will get L square and 2 into 2 4k L square divided by n cube pi cube 1 minus minus 1 power n. Whenever you will have the form 1 minus minus 1 power n like that, now we can check our answer completely depend on odd or even. So from this square term I am going to apply here n is equal to odd number. When I am substituting here n is equal to odd number, this minus 1 as it is remains, minus into minus plus. So 1 plus 1 2, 2 into outside term 4 8. So I will get the answer 8k L square divided by n cube pi cube when if n is equal to odd number. Okay, when I am substituting here n is equal to even number, this minus 1 converted to plus 1, so 1 minus 1 0, your entire answer becomes 0 when n is equal to even number. So your half-range Fourier series is depend on odd and even. So here your answer comes only for odd number. So from that summation we have to convert 1 to infinity, we converted into odd to infinity. So substitute this Bn in equation 4. What is our equation 4? This most general solution. Okay, from this equation we have to substitute Bn value. So I'm writing y is equal to sum of n is equal to 1 converted into odd to infinity. N is equal to 1 to infinity converted into odd to infinity because of our Bn answer. So here our Bn answer 8k L square divided by n cube pi cube into sin n pi x by L into cos n pi at by L. So we can simplify this equation. Y is equal to, we can take outside constant term. What are all the constant term here? 8k L square divided by pi cube. Why? Because we have to apply the values only for n. So we couldn't take outside summation n terms. So I'm taking outside 8k L square divided by pi cube. Remaining we can write as it is. Sum of n is equal to odd to infinity 1 divided by n cube sin n pi x by L into cos n pi at by L. This is our final answer. So we can recall what we completed in this class. So in this class I solved one problem from zero velocity model. So this is our problem number 1. Just I will recall. So in the previous videos I given working rule for how to find the equation for step 1 to step 4. So after that I started one problem. In this problem I find how to find Bn value. So Bn equal to 2 by L integral 0 to L f of x sin n pi x by L into dx. In this equation I substituted f of x equal to this k of Lx minus x square. After that I applied Bernoulli's formula. Based on Bernoulli's formula we are finding Bn value. Bn equal to 8k L square divided by n cube pi cube if n is equal to odd numbers. N is equal to even number, now your entire answer becomes 0. So I am going to substitute this Bn in our most general solution. Y equal to sum of n is equal to 1 to infinity Bn sin n pi x by L cos n pi at by L. So this equation considers your summation 1 to infinite number of terms. That means it's included odd and even, but our answer only depend on odd number. So the summation I'm going to write in the form of odd to infinity. Here even numbers are 0. Now you can substitute Bn value 8k L square divided by n cube pi cube in equation 4 sin n pi x by L cos n pi at by L. From this you can take outside constant term 8k L square divided by pi cube. Why it is constant? Because we have to substitute our values only for n. So I taken rest of the term outside. I consider it is a constant. And sum of n is equal to infinity 1 by n cube sin n by x by L into cos n by at by L. This is our final answer for this problem. Okay. So already we completed problem 1. So this problem 2 as a continuation of problem 1. A tightly stretched string with fixed endpoints x equal to 0 and x equal to L, initially displaced in a sinusoidal arc length of y0 and then released from rest. Find the displacement y at any distance x from one end at time t. Here the same endpoints are given x equal to 0 and x equal to L. The initial displacement there will be given k of Lx minus x square. Here they told sinusoidal. What is meant by sinusoidal? Sinusoidal means one equation. When we are using guitar, you will get this equation. Sinusoidal y naught sine pi x by L. So usually we are writing the wave equation and the condition already you know that how to write zero velocity condition and the suitable solution y equal to a cos px plus b sin px into c cos pat plus d sin pat, which is our equation 1. From this we have to apply condition 4 up to common for every problem in zero velocity model. Already you know that. I'm not going to teach about the steps, step 1, step 2, step 3, step 4. So because we given enough explanation for this in first video, so just I'm going to explain how to apply that condition f of x y naught n sin pi x by L in our equation. So in this equation 4 I'm going to apply condition 4. This is y equal to y naught sin pi x by L and t equal to 0. When substituting both the term, you will get this term y naught sin pi x by L is equal to summation n is equal to 1 to infinity bn sin n pi x by L. Here no need to find bn because whenever your function in the term of sin or cos, just we can equate both the side, we will get the answer. So here right hand side I'm going to expand this series. I'm going to substitute n equal to 1, 2, 3, 4, 5 like that up to infinite number of terms. See, first I substituted n equal to 1. I'll get b1 sin pi x by L. Next I substituted 2. I'll get b2 sin 2 pi x by L. Next I substituted 3. I'll get b3 sin 3 pi x by L. Similarly we can apply infinite number of terms. Okay. So now I'm going to equating the coefficient of both sides sin pi x by L. So sin pi x by L now left hand side you will have one term, right hand side also you will have one term. So equating the coefficient of sin pi x by L, I will get b1 equal to y naught. Remaining all b2, b3, b4 all constant values are 0. This b1, b2, b3 infinite number of terms I'm going to substitute in equation 4. But our equation 4 in terms of summation, we cannot able to apply directly b1, b2, b3, b4 like that. First, before going to apply the value, we have to expand this series. Again, you go for expand this series, apply n equal to 1, n equal to 2, n equal to 3 like that, you will get this series. Here already we know b1 equal to y naught, just substitute b1 equal to y naught and remaining b2, remaining all the terms are 0. Directly it will be 0. So substituting b1 equal to y naught, you will get the answer, final answer y equal to b1 sin pi x by L cos pi at by L. So this is our another model problem in zero velocity. First one will be function in terms of variable. Second one will be function in terms of trigonometric series sin or cos. Whenever you will have the form sin or cos, no need to find bn. Just you can equating both the side when substituting condition 4. Thank you.